Welcome student to today's lecture. We are still continuing with types of materials, and today we want to explore more about alloy steel. So an alloy is a mixture of more or different components to make a respective alloy material. So for instance, here we have steel. So in order to improve properties of ordinary steel, certain alloying elements are added in it in sufficient amounts. The most common alloying elements added to steel are chromium, nickel, manganese, silicon, vanadium, molybdenum, tungsten, phosphorus, copper, that the titanium, zinconate, cobalt, columbium, and aluminium. So each of these elements induce certain qualities in steel to which it is added. They may be used separately or in combination to produce desired characteristics in the steel. The main purpose of alloying elements in steel is to improve machinability, elasticity, hardness, case hardening, cutting ability, toughness, wear resistance, tensile strength, corrosion resistance, and ability to retain shape at high temperature. Also, ability to resist distortion at elevated temperature and to impart a fine grain size to steel. Like carbon, a number of alloying elements are soluble to produce alloys with improved strength, ductility, and toughness. Also, carbon, besides forming an intermetallic compound with iron, combines with many alloying elements and form alloy carbides. These alloy carbides, as well as iron alloy carbides, are usually hard and lack in toughness. Some alloying elements are added to prevent or restrict grain growth. Aluminium is considered the most effective in this respect. Others are zirconium, vanadium, chromium, and titanium. The addition of alloying elements almost always affect the austenite-ferrite transformation mechanism. Some alloying elements lower and some raises the critical temperature. The compositional and structural changes produced by alloying elements change and improve the physical, mechanical, and processing properties of steel. So what are the effects of alloying elements in steel? The chief alloying elements used in steel are nickel, chromium, molybdenum, cobalt, vanadium, manganese, silicon, and tungsten. Each of these elements possesses certain qualities upon the steel to which it is added. These elements may be used separately or in combination to produce the desired characteristics in steel. So the following are the effects of alloying elements on steel. Let's begin with nickel alloy. Steels contain 2 to 5% of nickel and from 0.1 to 0.5% carbon increment. This increases its strength and toughness. In this range, nickel contributes great tensile strength, yield strength, toughness and forming properties and hardness with high elastic limit, good ductility, and good resistance to corrosion. An alloy containing 25% nickel possesses maximum toughness and offers the greatest resistance to rusting, corrosion, and burning at high temperature. It has improved beneficial in the manufacture of boiler tubes, valves for use with superheated steam, valves for IC engines, and sparking plugs for petrol engines. A nickel steel alloy containing 36% of nickel is known as Invar. It has nearly zero coefficient of expansion, therefore it is in great demand for making measuring instruments for everyday use. Another element is chromium. Chromium improves corrosion resistance about 12 to 18% addition. It increases tensile strength, hardness, wear resistance, and heat resistance. It provides stainless property in steel. It decreases malleability of steel. It is used in steels as an alloying element to combine hardness with high strength and high elastic limit. It also imparts corrosion resisting properties to steel. The most common chrome steel contain from 0.5 to 2% chromium and 0.1 to 1.5% carbon. The chrome steel is used for balls, rollers, and races for bearings. A nickel chrome steel contains 3.25% nickel, 1.5% chromium, and 0.25% carbon. Is much used for armor plates. Chrome nickel steel is extensively used for motor car, crankshafts, axles, and gear requiring great strength and hardness. The next alloying element added to steel is tungsten. Tungsten has high hardness, wear resistance, high shock resistance, and magnetic reluctance. It increases ability to retain hardness and toughness at high temperature. It prohibits grain growth and increases wear resistance, shock resistance, toughness, and the depth of hardening of quenched steel. The principal use of tungsten steel are for cutting tools, dies, valves, taps, and permanent magnets. Another material is vanadium. Vanadium improves tensile strength, elastic limit, ductility, fatigue resistance. Also, it improves shock resistance and response to heat treatment. It also acts as a degasser when added to molten metal. It aids in obtaining a fine-grained structure in tool steel. The addition of a very small amount of vanadium, less than 0.2%, produces a marked increase in tensile strength and elastic limit in low and medium carbon steels without a loss of ductility. The chrome vanadium steel containing about 0.5 to 1.5% chromium, 0.15 to 0.3 vanadium, and 0.13 to 1.1% carbon have extremely good tensile strength, elastic limit, endurance limit, and ductility. These steels are frequently used for parts such as springs, shafts, gears, pins, and many drop forged parts.